Hello everyone, in this video we are going to see a numerical on light chapter. Let's look into the question. The radius of curvature of a concave mirror is 50. So I can write R equal to 50 centimeter. So where should an object be placed from the mirror so as to form the image at the infinite distance? So here U we are going to find, whereas image distance is given which is at infinite. So here there are two things they have given. One is image is formed at infinity and this is a concave mirror. So do you remember all the 6 cases of concave mirror? Just recall at which case where I can keep an object so that my image is getting formed at infinite distance. So hope you remember this concave mirror principal axis. So some two incident rays are coming. So the reflected ray is coming like both are in parallel. That means they never ever intersect. So I will be getting the image at the infinite distance. This is one among the case of concave mirror. Do you remember at which place the object will be reside in this case? Yeah, it is at focus. So whenever we keep an object at focus, we'll get an image at infinite distance. So this is what we are going to justify. And we'll look into this problem. So what is given? Radius u and v. I have to find u. So which formula we can use for it? So we can use mirror formula, right? 1 by f equal to 1 by u plus 1 by v. But here f required and v we know, u we are going to find. But how can I get f? F is nothing but half of the radius of curvature. So f equal to r by 2. So it's nothing but 50 by 2, which is 25 centimeters. So what is f over here? It's a focal length. So 1 by 25 equal to 1 by u plus 1 by infinite. So let it be 1 by 25 equal to 1 by u. What is 1 by infinite? It's nothing but 0. Then what is the value over here? U equal to 25 centimeter. So what is u? It's 25 centimeter. What about f? That is also 25 centimeter. So at the focus only the object is resided. So I'll be having a concave mirror like this. So here this is our pole and here is going to be the focus and this one is the center of curvature. So from C to P it is the radius of curvature which is 50 centimeter, and we found the focal length. Focal length is what? From focus to pole. So F equal to 25 centimeter. So at this point at focus only we are keeping our object. So when this object is sending the incident ray and which is incident on the mirror, so the reflected ray is going to come over here. So when an incident ray is parallel to principal axis, where our reflected ray will be forming, it is going to be passing through the focus. So this is the reflected ray, and even I can take one more ray, right? Because we have to find the intersection. So I am taking one more ray which is passing through the center of curvature. So what about our reflected ray? So this reflected ray also going to pass through the center of curvature. So if you closely look into this two reflected ray, it is going to move in parallel, so the image is formed at infinite. So this is how we justified our answer. So both f, that means focus, and the u both are having the same unit, that means same distance, which is at 25 centimeter. Hope you understood. Thank you.